Okay, so we had left off halfway through this problem right here, talking about finding the cosine and the sine. We determined that our x is 12, our y is 5, so we have x squared plus y squared is 169. To find the radius, well, it would be, if this were a circle, it would be the radius. That's where it kind of comes from, that r comes from. Let me show you what that looks like. So if this were a circle, a point on a circle, which we'll talk about in just a minute, that would be the radius. You guys see it? That would be our radius. Let's make that a pretty color. Let's make it style. Okay, so that's our radius right there. And we determined that our missing side, our radius, would be 13. So our cosine is x over y. I always do cosine sine y because it goes x, y, and then y over x. I know, that's what we did it for this problem. So our cosine is going to be our, and that's how it's worded here. So our cosine is our x, so it would be 12 divided 13. All right, x, 12 divided by 13, and our sine would be 5 divided 13. Okay, that would be, those would be our ratios. This is going to come important next week because next week we're going to talk about actually finding the angle given the ratios. And you have to know cosine is the x over r, sine is the y over r, and tangent is the y over x, okay? So let's take a look. That was this problem right here. We're going to go through B, and then I guess we'll talk about C. So B, let's do this. So let's see. So B, boom, let's take a little picture. A picture, send it to our page, and then, because we're just going to, boop, 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 and then we're going to go, I also want to have a picture of this just to keep this handy. Boop, that's our other thing, okay? All right, and let's scroll on down. And here we have the tangent and that and that. So here, the first step we have to do is we have to actually sketch this. So I think what I'm going to do, I'm feeling a little lazy, all right, is I'm going to go up here and I'm going to take a picture of this. Now I know it's going to be -6, +4, so I only really need this part of our axis, right, to draw at that point. So let's do it. So that's our first step, is we want to visualize the problem. So we want to visualize -6 in the x direction. So 1, 2, -3 would be here, and then -6 would be here. Okay, you guys see that? All right, I don't want to put too many numbers on here. So -6, and then 3, 4 would be boom, boom, 3, 4, 4 right here. So when we go to draw this this little shapey shape, all right, let's make it nice and big. So the shapey shape, we would start at 0 and we end right here. And that would be our angle. All right. And it terminates right here. Okay, so to kind of visualize this angle, we're going to be looking at this triangle right there. Oop, 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 oop. I'm using a mouse to do this. It's not perfect. Okay, so we visualize that from here to here is 4. So our y is 4. And from here to here is -6. So our x is -6. That's something we would visualize, all right? So don't let these little ghost numbers throw you off. I'm actually going to make them ghosts. They're ghosts. Okay, and they're disappeared. So that's our point. So step number 1 is we want to find our missing side. Now, we know to find the missing radius, that would be what the number that goes right here. We know that we're going to use our formula. So it's x squared, all right, plus y squared is equal to that number squared, r squared. So for this problem, right, we just want to kind of think of this formula, and we want to put in a 4. So I'm going to write that in because maybe you're taking notes. You can write in too. So 4 squared, and then -6 squared. Now notice that's in the parentheses equals r squared. So let's get out our calculator and let's do it. So we're going to do 4 squared, and I'm going to put this in parentheses because I'm obnoxious with it, because I'm going to put it in parentheses. And -6. Delete -6 squared. And we get 52. So we take the square root of 52. Oh, we get this ugly decimal. I think I'm going to leave it as a square root because that's so ugly. So I'm going to leave this as square root 52, which we could, I guess, simplify using like a tree diagram, but I'm not going to do that. And we want to find the sine, the cosine, and the tangent. All right, so cosine, the sine, and the tangent of these. All right. So the cosine is our x, so our x here is negative 6. So it would be negative 6 divided by, let's see, do I have a square root symbol? I feel like I should. Square root, and sorry, yeah, let's do that, square root 52. Okay, I'm going to use that in a bit. And then our sine would be 4 divided by square root 52, and our tangent would be 4 divided by negative 6. There we go. Boom, boom, boom. Done. Okay? So that's what we have, cosine, sine, tangent. That's how we do that problem. Let's take a look at our problem for part C. For any angle with measure theta, is it possible for sine to be greater than 1, for cosine to be greater than 1, for tangent to be greater than 1? Okay? So let's think about this. If sine is more than 1, so let's just talk about this problem. Let's do it. So sine, that's not it. Okay, I'm done with that. So sine is greater than 1. Let's take a look at that one first. So sine is greater than 1. So we have to remember that sine is our y divided by our r. So if we're looking at like a triangle that would make this shape, right? Y, there's my triangle. Isn't it beautiful? Isn't it beautiful? So that would mean that if that's going to be bigger than 1, and here's our y over here, that would mean that this side would need to be bigger than the radius. And that's not possible because the radius is the longest side. So not possible. The radius has to be the longest side. So this is always going to be bigger. So let's say that this is 9. This would have to be 10, right? Okay. If this was 12, let's say I was like, oh, well, what if this is 12? Oh, let's not even do that. Let's say this is 2. Well, this has to be smaller. This would have to be something like 1. It would have to be less than. So since the radius is always the longest side, it's never the case. Okay, so no. Nope. Sine is always less than 1. Okay? So that's never true. False. False. All right, and we get the same thing if we think about this in terms of cosine instead. The same result, because cosine, and I just made that so ugly, cosine. Let's see if I can do what I want here. There we go. So if we cosine greater than 1? Well, cosine is, we do the same kind of thinking. The only difference is instead of looking at the x or the y, we're now going to be looking at the x. And x over r, that's not true. Cosine, the same thing happens here. The radius is still the longest side. So, that can't be possible. All right, don't spend too much time on this. If you don't get it, it's cool. All right. But it'll make more sense when we start talking about the graphs of these functions, which, when are we doing that? Which is something I think you'll talk about when you have me for IM3. We'll do a fun little project with spaghetti. All right, so let's see. So the next one we have is the tangent greater than 1. Well, let's see. So the tangent is our y over x. Can you set up a triangle that has a y? Maybe I didn't draw this the right way. That's bigger than 1. Well, not the way this is drawn, but what if we took this triangle and we're like, oh, let's make it a big top. Big top. So let's say we're going to make this guy a big top. So look at him. Look at that big top triangle, right? So that triangle, right? We can make it even more big top than that. See, big time. There we go. The y is bigger than the x. So if you divide a number that's bigger, so if you say I'm going to divide 10 and then this is 4, right? 10 over 4 is definitely bigger. If you have 4 pizzas and 10 friends, everyone is getting more than 1 slice of pizza. Okay? So yes. Yep. Yes. That's the answer. Okay? So the last thing we're going to do here is I'm going to give you guys some time to work on this problem. And, oh man, I forgot to write the problem in. So let me type the problem in a second. And what you're going to be doing is, suppose the terminal side of an angle of standard position with measure theta contains a point. So you're going to sketch the point and find the sine, cosine, and tangent of that angle. So okay, so here's your problems. All right, let's just kind of go through the steps, all right, to what I want you guys to do. So for each problem, you want to plot the point on the x, y-axis. That's step number 1. Step number 2, all right, is that you want to find the missing side r, okay? So for that, we're going to use x squared plus y squared equal r squared, okay? That's what we're going to do. Let me just make this fancy. All right, and then you want to use your ratios. So that's our very last step, is you want to use the ratios. Boom, that's our very, very, very last step. So what are our ratios? Let's go find them. We did them. So if you didn't write them down, they're right here. Okay, so let's just copy this to clipboard. We can put it on the page. Okay, send to clipboard. And there we are. So, all right. So I'm going to encourage you guys to, this is a good practice, all right? So I'm going to encourage you guys to work through this problem, all right? So I'm going to have you guys work through it. So let's see, let's just search for a stop sign. Search. See if there's one. Picture of a stop sign. Yeah, I don't like that guy. Stop sign. You guys get to be the ones to discover where this is with me. That's not a stop sign. Man, that is so, like... Yeah, I tried to put a stop sign in here. I couldn't do it. So I want you guys to stop, all right? Stop and work on these problems. Do these, all right? So take a couple minutes. It might take 10, 15 minutes, right, to do. But work through it. You got it. You can do it. Okay. So this is the answers I came up with. All right. If you're looking for the math I used to find the radiuses, I know I did it here. Where is it? Right here. Okay. So this is the math I used. So let's just take a little picture. Let's make that a little bigger. Escape that. So let's make this a little larger so we can see it all. So this is the math I used. I decided to leave the last one as just the square root for some of them. So that's where that came from. So if you had some questions on the math behind the radiuses, that is it. So I'll just leave this up for another minute or two so you guys can just kind of look and check your answers. Proving to be a little more challenging than I thought. Okay. I'm going to put this so everyone can see it. It's up there. I don't know. If you're on like a phone, this is going to be hard to see though. So, but that's the math I use. I did this, x squared plus y squared. I think I switched these two. It doesn't matter really the order if you switch them. Okay, that's it. Great job today.